I want to talk a little bit about the volume of metal that you're going to be pouring. Right now this is unplugged and off. This is our crucible that we're going to use. You guys have used this little furnace already where we put the glass tubes in and did the smelting of the lead tin alloy. What we have on this crucible is it's going to be about 3.5 inches of molten metal that I'm going to allow in there, and about 1.3 inches, so 1/300 in diameter. So you can figure out the volume of material you're going to have. So when you guys make your mold and your pattern, you're going to get the pattern, which is going to be a nice little wood block. You can measure the volume of that and size your riser and make sure everything is going to work with this amount of material. So don't make a riser that is larger than the crucible is going to allow. You need to size everything properly. Each group gets 1 pour out of this per mold, and we're going to have to take time and recharge the furnace. So I'm going to kind of be going over that. I don't want anybody messing with the furnace or anything. This is really nice because I'm going to be able to come in here and pour into your mold much like this. So if you can, locate your pouring basin off to the side so I can pour in there and get that height and the velocity decreased. So let's learn how to make a mold, and we'll see you guys in lab. Talking about how to make our sand molds for our lab. The first thing we're going to need to get is a metal pan like this, 1 per group, and we're going to have a board that looks much like this that we can use as a flat surface in the pan because sometimes the pan is wavy on its surface. So we're going to put that board down inside there. It's clean. And then we're going to secure a couple of flasks, and these are our flasks for our cope and our drag. So the drag is on the bottom and the cope is on top. So I'm going to put one on here, and I'm going to start with the drag first, and it doesn't matter which board because they're the same. But I'm going to make basically a sand brick for this portion of the lab. So to do that, I'm going to use this screen that is a number 6 screen. And this is going to allow us to break the sand up initially to get really good contact with the part. So actually, the contact with the part is going to be the side that's down. This will be the very, very bottom of the drag when I flip it over. So I want some good sand to make contact with the part. So let's talk about our sand here. I've got a bucket right here, and we know this is clean sand. Sand will be marked in another tote that's been used. So let's talk about our sand. Our sand is basically a really fine sand with bentonite clay with some water added. So if I open this up and I leave it open, the moisture is going to start coming out of the sand. So I like to keep the sands kind of closed. And basically if I grab that sand and I make a wad, it's going to hold its shape. So this has got about the right amount of moisture that I need for this lab. Okay, and I don't want too much moisture in there or I'm going to have issues with steam and vapor coming off. So we want just enough water in there to make the clay want to form a nice clod right here. So the purpose of the screen is if we have any artifacts or foreign objects in the sand or hard pieces, it will break up and won't come in contact with the sand cavity. We have a little cup, and what we want to do is keep your area clean. This does not mean we need to have sand all over the place. Just take it neatly, put it in the screen, and what you're going to do is come over here and use a plastic trowel and just kind of get that sand down into the drag box. Now, we only need this 1 cup full, and it's going to give us enough sand that's high quality sand, okay, on the very bottom that's going to become the top of the drag. And so once I get that done, that looks pretty good. I'm going to set my screen over here. I've got a nice layer of sand in here, and that's going to become really high quality sand. What I can do at this point is just put regular sand in there and fill that up. And this is just going to be filler sand. So I'm going to come in here and fill up this pattern with this regular sand. And again, you don't want to get so much out that you just have tons in your box. We just want to keep it somewhat clean. Now, that sand is somewhat compressible. I can compress sand almost 1/3 of its height. The amount that I compress it is going to change the permeability and the strength of that sand. So I want to just kind of get it where it's going to be flush down there. I'm going to get enough sand in here that I can make this drag with. And I'm going to have to make it a little proud, meaning a little raised. And I'm going to get some more sand. And what I'm going to do is use this nice little board right here. Normally you have what in industry what we call a squeeze jolt machine. Usually it squeezes the sand down and it packs it down. We don't have that luxury here, so what we're going to have to do is use a board to kind of pack that sand down. So what I do is with the sand being raised higher than the mold, I'm going to come in here and just pack that down. Now I probably have it about 3/4 of an inch higher. Sometimes you can come in here and do this number and tamp the sand down. Okay, and I can see now that it's a little bit lower. I'm going to add some more sand. And I'm adding some sand on there. And at this point, I can probably just come in there and use the board to kind of pack it down so it's nice and flat. And I'm putting my body weight on there to force it down. And I find that's going to look pretty good. The thing we're going to do next is a process called screeding. So we're using two technical words here. Screeding is where we're going to come in and remove that unwanted sand from the top. So we're just going to come in here with that board flat and just kind of saw cut it, and it is now coming off. Okay, so now I have that sand off of there. Another technical term that we had was the initial use of the screen. That's called riddling. I'm riddling the sand down, getting better quality sand. Now at this point, I can pull this up, and I'm going to have a really nice surface of sand on the bottom. I'm going to set this off to the side carefully, and my drag is now made. Okay, this being the bottom of the drag, or the top of the drag, and this being the very bottom. So eventually I will flip this over. So what I want to do next is I'm going to clean all my sand off here, and it's still fairly good fresh sand. So I'm going to put it back in the bucket so that I can reuse it and recondition it. Okay, so I've got my sand out of my tray now. I'm not making too big of a mess. What I want to do next is I want to put my cope board on this. And so I've got all the unwanted sand out of there, and I am going to get my part that I'm going to be casting. This is my part, so you may want to take some dial calipers and identify a spot on your part that you can measure, height, width, and thickness, those 3 dimensions. Record that because that's the size of this part, the pattern. This is going to be our pattern. I'm going to put my pattern straight down in the sand where it sits flush with the draft coming up on the side. So there's another technical term, draft. What do we need draft for? We need to have draft so that when I remove the sand or the pattern from the mold, that it releases. So I need to have a few degrees, maybe 5 degrees of draft, for example. Depends on your draw and your height and what you're pulling against. I want it to be able to release. So I'm going to have some taper, basically, some angles on those sides where they're drafted out. I'm going to put that draft pulling towards the top on here. I'm going to find out where I want to put that in there, and I'm going to put my part in there knowing where it's going to be. Now that's going to be your call is what you want. And what I'm going to do is go back to that other term we had, riddling, and I'm going to come back in and put some more sand back in here, okay, so that I can come in here, and I'm going to use this little device again and kind of get that sand back down in there. So we have high quality sand up next to the part. We want good sand in there. So we are riddling our sand down in there. Let's see how much I've got. It's almost covering the part. Maybe a half a cup of this again would be enough. And I'm going to call that pretty good, and I'm just going to pour the rest of the sand in. Okay, tap it out, get that cleaned out so I'm not making a big mess here. So I've got most of my high quality sand in there that I want. Again, what am I going to do? I'm going to come in here and just fill it up with filler sand. I've got the good quality sand up next to the casting where it counts. And now I'm going to come in here and just start putting some sand in there. Again, don't press it all down and then try and press layer and layer on it. You want that sand to bond to its previous layer. The other thing is when we do this, the sand, there's nothing groove-wise to hold the sand inside the flask. So sometimes I will tamp, and I probably did it quicker than you thought because I do this a lot, and I kind of move my hand left and right, tamping to the sides. Or what you can do is come in here and slightly press to the sides like that, and it will help push some sand, putting some forces outward. So I just did a little bit of that. I'm going to go ahead and fill this thing up, and I'm going to come in here and tamp it down lightly. Now I have my part in there, so I want to be very careful with my tamping, and it's going to compress that sand down. And I'm just going to come in there and nicely tamp my sand down so it's compressed. Now I'm not really pressing hard. I want to just press just enough. You're going to have to experiment with that. You'll find out if you did it right or not, because when you lift that up, your sand will fall out and your part won't stay in there and your sand won't be compressed. So it's kind of a learning curve, and you just have to learn that. If I was in industry, I'd have a squeeze jolt machine, and I could adjust the pressure for the surface area I have, and it would put the right amount of force that I need on there. Now again, I'm going to come in here and pack that sand down, squeezing it with the board, and I'm just kind of rotating it down on there, and that's looking pretty good. And then I'm going to come in here and just screed that sand off again. I'm taking it off where it's going to be nice and flat on the top part of the system here. So now I've got my sand packed in there, and I want to cut a hole in for my pouring basin and my sprue. Now, probably what I would want to do is come in here and go ahead and make a hole for my pouring basin. So again, I want to locate my pouring basin somewhere close to the edge of the part. So maybe I'm going to locate it to the middle side here, and I'm going to use this little spoon. And we have a variety of tools here that you can use. And I'm just going to spoon out a nice little divot out of that sand, so that this is where I'm going to pour that metal. Now the idea and the concept behind a pouring basin is that pouring height. If I pour that metal in and it pours, I want it to go in here and then roll over an edge down a hole, which is my sprue, letting the metal go down into the runner system to my casting. Okay, so I have a nice little pouring basin. Again, guys, this is going to be smaller than the indention of a golf ball. You know, a third of a golf ball or something. I have a nice, and I'm going to come in here and pack that down and get all that loose sand, and that looks really good. I got a nice little divot right here. Next thing I'm going to do is you have a variety of sprue cutters that you have. If you want to try a tapered one, you can. I've got a couple of different ones. I'm just going to use a straight cutter, and I'm just going to come down to the side of that divot, and I am going to push down all the way to that board. And what's happening is I'm going to core out a piece of sand here out of that mold. So I now have some sand in there. So what I want to do is come in here and just lightly tap this with my hand and get the sand out, and then put it back in the pile with the rest of the tools. I'm going to come in here and slightly press this sand down so that I have a nice pouring basin. And I'm going to take a nice picture for you guys and put it in the video here of what I've made, and you can kind of see my pouring basin. And so on that, you can look to the side there, the right, and the metal's going to pour into the basin, and it's going to come up and then go down there. So that as I pour, if I fluctuate my pour, I'm going to have a nice pool of metal, and it's going to go down that hole where I can connect to my runner system. So now it's time to do some runner cutting on the other side. So what I'm going to do is, I've got all the sand and unwanted stuff off the top of this. I'm going to come in here and lightly turn this to the side, and I'm going to set this up here, and I'm going to clean up all this extra sand and return it to the bucket because it's still got the right moisture content. I'm going to clean all the sand off of everything, put the sand back in the bucket for the next group to use, because now I'm ready to come in here and do a little cutting of my runner system. Now if I look at this, I can see neatly on this, I can see the pattern inside the cast and the sand right there. So what I'm going to do is work very carefully, and what I find is every time you lift this up and turn it down, you chance of pouring your sand out. So what I'm going to do is come in here and put this board on the side that I made my sprue and pouring basin in, and I'm going to use that to help lower my part down very carefully. Now what I'm going to do is I have a variety of tools here that I can come in here and connect to my casting. And so I'm going to come in here and just very carefully come in. And I'm not going to do a really good job here, guys. I'm going to do a really bad job of a runner system. I'm just going to cut something that goes directly from the sprue into the casting right there. Okay, so this is going to be a really bad example of a casting. I'm going to clean that off. And I now have something that the metal just goes straight from the riser or my sprue. And I said the word riser. What does a riser do? I don't have a riser on this. So if you need to make a riser, maybe this larger sprue cutter, you could push down in here and push down a ways and hook that in and make a riser. Or you could use the spoon and carve you out a riser. And again, you want to measure your riser, document all your runner system, the sizes, make drawings and dimensions of those for your lab sheet. And then once you get all that done, what you're going to do is come in here and carefully, we have nice little tools that you can use. We're going to pull that pattern out of there. Now, a lot of times we can turn that around and try and tap it out, but what's going to happen is the sand's going to fall out. So what I'm going to do is carefully come in here and lift each side and I'm going to lift my pattern out of the hole. Now, what I'm going to do is when I turn this up on its side, is I'm going to blow very lightly and release any loose sand that's on there, sand that I don't want to have. So what I have is on this side, I have my pouring basin and my sprue hole. My sprue hole is connected to a runner. That's not a good design, guys, going straight to the cavity. This thing is going to have all kinds of issues. Okay, so what I'm ready to do now is package this ready for casting. So what I'm going to do is one last cleaning job, put the remainder of the sand back in the bucket, and at that time I'm going to go ahead and put my drag down correctly, okay, onto my part. So I have my drag located. Now I'm ready to put my cope onto my part, and I'm going to come in here carefully and put my cope down, and this is ready to pour. So we'll take this over to the pour station, and I will pour metal in for you. It will go down in there. We'll let it cool, and then we'll see what kind of casting we've got. Now then, this lab is about you guys getting to design and experiment. So you want to build one, document it and see what happens, and then turn around and let's build another one in your group and see if you can improve the quality, the solidification of your part. Eliminating the top of the part. Sometimes it wants to see a concave shape of the part because it didn't get enough metal and it froze and it didn't have enough metal from the riser. That could be a defect. You may have porosity where we pour in and get too much air going in. That could be, and we don't have it choked off enough. That could be an issue. You don't have a big enough riser, and we're going to see shrinkage, those irregular, jagged type features in there versus round ones that represent gas porosity get in there. So we're going to see those kind of different defects in there. So again, this is going to be hot. I'm going to do the pouring, and when I get it over, we'll have a pan. We'll break out our sand in here, and then this sand will go in the other tote, not back in the sand that's molded and ready for the groups to use. So be sure to document how you design your runner system and put that in your lab sheet.